Today we are going to see about registers. What do you mean by registers? Means registers are storage devices. It is used to store data and it is used to retrieve the data. Registers, it is a combination of flip-flops. Flip-flop means each flip-flop can able to store only one bit of information. For example, if you are having 1011 means how many flip-flops are needed to store the information? 4 flip-flops are used to store the information. Now closer. 1011 means 4 flip-flops are used to store the information. So therefore, group of flip-flops are called as registers. Registers can also be called as a program counter. We are going to see about register transfer. Next one is a register transfer language. Next one is microoperations. And then fourth one is a central processing unit. Registers are low-level building blocks of digital systems. And then computer registers are denoted by capital letters. For example, R1. R1 is a register. R2 is also a register. Registers can also be called as program counter, memory address register, instruction register, memory buffer register. These are all the other names for performing a registers. Register is a very fast computer memory and it is used to store binary information. That one is given here. And then register is a group of flip-flops. Each flip-flop can able to store only one bit of information. And then suppose if you are having n is equal to 4 bit abdina, ethana flip-flop needed? 4 flip-flops are needed to store the information. And then register means it is a group of flip-flops and we have already seen about the gates. What do you mean by a gate? Means AND gate, OR gate, NOT gate, NAND gate, NOR, exclusive OR, exclusive NOR gate. Therefore, register is a combination of flip-flops and gates. And then next flip-flop means it is used to hold the binary information. And then here we are having a various type of registers. And then next simplest register is it contains only a flip-flops, no gates. That is called as a simplest register. Next. Other names for the registers are accumulator. Accumulator is a one type of register. It is used to store a 0 bit. 0 bit means there is no information available in the accumulator. Previous one is stored in the accumulator register. Accumulator is a most common register used for memory. It is a tiny storage device. And then next one is a general purpose register. General purpose register means it is used to store intermediate result. Intermediate result means in the program we have to store data. Suppose A plus B equal to C. That intermediate result will be stored in the general purpose registers. Intermediate results are stored in the general purpose registers. And then next type of registers are special purpose register. First special purpose register is a memory address register. It is used to hold the address of the memory. And then next one is a memory buffer register. What is the purpose of using a memory buffer register? Means it is used to store the data and it is used to retrieve the data from memory. That is called as a memory buffer register. You know that buffer is a tiny storage device. Buffer is also a tiny storage device. And then next one is a program counter. Where it is used means it is used to fetch the instructions from programs. Program counter is incremented by 1. Suppose if you are giving a program, first name, then hash include studio.h means the program counter will points to the first program. Initially program counter value will be equal to 0. Then what will be the first one? PC assigned to PC plus 1. Then 0 plus 1, it points to the first instruction of the program. The first instruction is executed means program counter is automatically incremented by 1. Already program counter having the value 1. Now it is incremented 1 plus 1, 2. Second instruction will be fetched. Fetching means reading instructions. And then second instruction is executed. What is the work of a PC means it is used to increment the program counter. Program counter means it points to the first line of the program. That PC is also called as a register. And then next, instruction register. Instruction register means you are using several instructions in the program. That instructions are stored in the instruction register. You have to know the difference between the program counter and instruction register. Program counter is used to increment the program lines. And then if first program is executed means automatically program counter is incremented by 1. Second program is executed means automatically it is incremented by 1. Therefore third program is executed. When it will stop this? Until the program comes to one end. There is a two type of end, temporary end, another one is a permanent end of the program. Temporary end means which one is called as a temporary end? Stop is called as a temporary. And then next, end if is called as a permanent end of the program. Until it executes a last line of the program, it executes a program counter. Instruction register means what you are using in a program that will be stored in a instruction register. It is also stored in a memory. That purpose only we are using a instruction register. So what are all the various names for registers means memory address register. Second one is a memory buffer register. And then next one is a program counter. Fourth one is a instruction register. Apart from this, we are also using accumulator as a register. And then next one is a for intermediate result storage purpose, we are using a general purpose register. Therefore, what are all the different names for registers means accumulator register, and then second one is a general purpose register, third one is a special purpose register. These are all the various names for registers. Next one. Registers are always represented by capital letters. For example, R1, R2. R is a capital 1. Register 1. And then next R2 means register 2. And then R3 means register 3. And then it is also named as a PC. Here, what are all the various names means memory address register, program counter, instruction register. Here we are using a single entity that is named as a memory address register. And then here the register is, how many bits are stored in this register? 8 bits. The 8 bits means how many group of flip-flops is present here? 8 flip-flop. Each flip-flop is used to store 1 bit of information. Here how many flip-flops are used to store the information means 8 flip-flop. This is named as 0 to 7. For each flip-flop, it can able to store only 1 bit of information. Therefore, the length of the register is 8 bit. 8 bit is named as 0 to 7. And then next, here how many length of the register? 0 to 15 means the length of the register is 16 bit. This 16 bit register is classified into 2 types. First 0 to 7 is named as a lower order bit of the program counter. Lower order bit means how many bits are used in the lower order bit? 0, 1, 2, 3, 4, 5, 6, 7. And then next 8 to 15 are classified as higher order bit. Here PC. PC means which one is used? Program counter. Therefore, if the register is 16-bit means it is classified, it is divided into two parts, lower order and then another one is a higher order bit. Lower order bit having a length 0 to 7. Next 8 to 15 are classified as higher order bits. Lower order bit is represented as a PC of L and then higher order bit is named as a PC of H. Suppose if it is a 8-bit register means it is named as a R1 0 to 7, that is a 8-bit register. 16-bit is divided into two types, lower order bit and then another one is a higher order bit. Lower order bit 0 to 7, higher order bit 8 to 15, therefore 16-bit registers. Next we are going to see about the register transfer. Here what is the purpose of using arrow means it is a replacement operator. What is the purpose of replacement operator means the content of register R5 will be moved to which one? Register R3. Therefore register R5 oda content full enga move ஆயிரும்? Register R3 க்கு எந்த content வந்து change ஆகாம இருக்கும்? R5 oda content வந்து remains the same. Which content will be changed? R3 content will be completely changed because it copy the content of register R5. What is the purpose of using arrow means it is a replacement operator. It changes the contents register R5 to which one? Register R3. And then next, suppose if you are using a R2 assigned to R1 means which content will be moved to which one? R2 content moved to register R1. This is an example for a register transfer. Suppose in program statement if you are using if P is equal to 1 then R1 assigned to R2. What is the purpose of using this statement? Conditional? R2 statement. If the condition is false means the statement will not be transferred. That is the purpose of using a control statement. If P is equal to 1 means the transfer should be occurred. If P is equal to 0 means the transfer should not take place. That is the purpose of using a if then statement. It is an example for a conditional transfer statement. Conditional means P is equal to 1 means register R1 content will be moved to register R2. It can also be represented as P colon R2 assigned to R1 assigned to R2. If P is true, abdina, what is the purpose of using? Register R1 content will be moved to register R2. If P is equal to 0 means the statement will not be executed. Therefore, P is called as a conditional variable or a Boolean variable. Instead of writing a if then statement, you can also write this P colon R1 assigned to R2. Instead of using if then statement. In program only we are writing a if then statement. Here we have to mention only P colon R1 assigned to R2. Here P is a control variable or a Boolean variable or a conditional variable. Here when the transfer will takes place. If P means P colon R1 assigned to R2 you have given, how many time it will take means it will take only one clock pulse. When it will transfer entire content to this one means, for example, here a positive clock pulse occurs. Occurs means T, starting time T, and then when the complete transfer will take place means at the next clock pulse it will end. That is the entire content will be transferred. It will take only one clock pulse to transfer the content R1 to R2. That is an example. Clock pulse. How many clock pulse it will take means only one clock pulse. Here we are using a positive, negative clock pulse. Positive, negative. Here it starts positive clock pulse, and the next positive clock pulse, entire content will be transferred. It is an example. Here, what is the purpose of using this diagram means, if P is equal to 1, what it will happen? R1 content will be transferred to R2, and when it will take means at the clock pulse 1, T time it starts, when it will end means T plus 1, completely it will end. That is, content will be transferred. Next, suppose if we want to give a two statement, that is two statements means P colon P is equal to 1 means register R5 content will be moved to register R3, and then next instruction register is moved to memory address register. Therefore, two statements are simultaneously executed and it is separated by comma. Therefore, if P is equal to 1, two statements are simultaneously executed. It is separated by comma. Two statements separated using a comma. If P is equal to 1 means these two statements will be executed. If P is equal to 0, the two statements will not be executed. It is an example how the two statements are separated using a comma. Next, registers are represented using a capital letter, and how we will represent a register means MAR. All the letters should be capital. And then next, register R2. It is also one way of representing a registers. And then next, parenthesis means, what is the purpose of using a parenthesis? For giving values. PC of H. What is the purpose of using a PC of H? Higher order bit. PC of L means lower order bit. Here H means how many bits are used in higher order bit? 7 to 15. Next, L, PC of L means 0 to 7. So it denotes a part of a register. Parenthesis denotes a part of a register. Here if you are giving a PC of H means how many bits are used? PC of 8 to 15. அதுக்கு அடுத்தது PC of L means 0 to 7. You have to use here. Therefore, it denotes a part of a register. Parenthesis. Next, arrow. Arrow means it is called as a replacement operator, and then it is also used as a transfer of information from one register to another register. And then next, here we are using a two micro operation. B assigned to A and then A assigned to B. These two micro operations are separated by comma. Next, here we are using, instead of using a registers, here we are using a bus. Bus means a group of wire lines. That is called as a bus. A large group of lines are transmitted, large group of wires, a large number of cables are transmitted from one device to another device means that is called as a bus. Here, register R1 content will be moved to a bus, and then next bus content will be moved to register R2. It is just an example for a register transfer. These two statements are separated using a comma. Next. Using registers, we can perform 4 micro operations. First one is a register transfer micro operation, and then next one is a arithmetic micro operation, and then next one is a logic micro operation, and then next one is a shift micro operation. What do you mean by a micro operation? An elementary operation performed on data stored in registers. You can say an example. How we will perform a register transfer means R2 assigned to R1. It is an example for a register transfer micro operation. You can say an example for a arithmetic micro operation. How it will perform using a registers. R1 plus R2, it is stored in which register? R3. The R1 plus R2 assigned to R3. It is an example for a arithmetic micro operation. You can say an example for a logic micro operation. Huh? Use R1 and R2. That is an example for logic micro operation. Shift micro operation. Both the shift we can perform using a registers. How we will perform? Okay. We can see an example. For micro operation means an elementary operation or a basic operation performed on data stored in registers. That is called as a micro operation. 4 type of micro operations are performed. First one is a register transfer micro operation, and then next one is a arithmetic micro operation, and then next one is a logic micro operation, and then final one is a shift micro operation. Already we have seen about the register transfer micro operation. Suppose if you are taking arithmetic micro operation means normally what are all the operations should be performed in arithmetic micro operation? Addition, subtraction, and then transfer, increment, decrement, addition with carry, subtraction with borrow. These are all the operations, the basic operations performed in the registers. Next one. Logic micro operations means the basic logic micro operations are clear. Clear means what it will do? Clear micro operation. Everything should be stored as 0. If you are storing 1 0 1 1 means clear operation 0 0 0 0 will be stored. That is the purpose of using a clear, and then AND gate A and B or R1 and R2 AND gate is used. Next R1 plus R2. Therefore you have to use a which one? Union means OR gate, intersection means AND gate. And then AND gate means you have to use R1 dot R2 the whole dash or whole bar. That is a NAND gate. And then next NOR gate means R1 plus R2 the whole dash. That is used in a NOR gate. Transfer means R2 assigned to R1. And then next exclusive OR means A or circle plus B. That is a exclusive OR gate. Next exclusive NOR gate means A circle plus B the whole dash. And then next complement means A dash, A dash, B dash, whatever it may be, it is also a complement. And then set all ones, where it is used, set all ones. Suppose if you are having the value 1 0 1 1, set all ones means 1 1 1. All the 4 bits are set as 1. Next one. Next, in logic micro operations, I have to clear only a selective bits. What we have to do means we have to use B as a key. Here B value where it is set as 1, first bit and third bit. That bit only set as 0 in A register. Therefore, what is the output? B value will be key. B is a key value. First bit, third bit is activated as 1. That key value will be implemented in A register. First bit here 1, it is cleared. So 1 will be changed to 0. And then next third bit, third will be changed to 0. Therefore, what will be the answer? 0 1 0 0. This is called as a selective clear. Only the particular bits are cleared. Suppose if 0, 1, 0, 1, first bit and then last bit, what is the output? Huh? The B key value will be first bit is 1 ma. Next last bit only 1. What is the output? First bit is 0, 0, 1, 0. இங்க பாருங்க, இங்க என்ன வேல்யூ இருக்கு? 0. அப்ப அதுதான் வந்து என்ன கிடைக்கும்? It is a output. அப்ப இந்த இடத்துல மட்டும்தான் 0 ஆகும். 0, 1, 0. Suppose the center 2 bits are B value, center 2 bits are activated as 1, 1 means what is the output in A? 1, 0, 0, 0. Here already A has a value. This is a key value, pa. What is the purpose of using a B means the particular bit only changed to 0. This is a key. B is a key. A is a input. You have to change the value according to B. This is called as a selective clear. Where the B value is set means first bit, third bit. Therefore, first bit is activated as a 0. Third bit is activated as a 0. Remaining bits are all same. அப்ப இங்க என்ன வேல்யூ கிடைக்குதுன்னா 0, 1, 0, 0. Are you able to understand? B is a key value. A is a input to the system. According to the key value, A input is changed. According to the B key value, A input is cleared. That is called as a selective clear. Selective means only selective bits are taken from the B. That key bit is changed from to 0 in A input value. This is called as a selective clear. Selective means B is a key input value. A is a, we are giving a input. Next, what do you mean by a shift micro operation? Shift means there are two type of a shift. First one is a logical, right logical shift, and then next one is a left logical shift. Right logical shift means it is moved to right side. Therefore, which one is will be deleted? First bit is moved to next, and where it is moved means the last bit value will be moved to this place. Therefore, we have to insert 0 here. Last bit value is 0. That is last bit value nil. Therefore, we are including as a 0. And then similarly, left logical shift means where the bits are moved means this bit will be moved to next place. Therefore, here we have to include 0. Here we have to include a 0 value. Shift left means it is represented using a SHL. It is an example for shift left, logical shift left. And then SHR means logical shift right. These two operations are used for shift left and shift right. And then the examples are shift right, register R2. Again, the content will be moved to register R2. And then shift left, R3 means again the content will be stored to register R3. In shift left operation, where we have to insert a 0? Right side. Shift right. Where we are including 0? Left side. In shift left, right side 0. 0 include means that bit is deleted. Therefore, we are including 0. You just know these two. One, SHR is used for shift right. SHL is used for shift left. Next slide. Next, the last bits are deleted. Therefore, we are using a circular shift left, circular shift right. Circular means the discarded bits are stored in the this one is the last. Which one is the first? Last bit is stored in the first one. This one is the last. This one is the first bit. The last discarded bit is stored in the first place. This is the use of a circular shift left. Therefore, no bits are discarded or deleted. That is the purpose of using a circular shift left and circular shift right. In circular shift left, which bit is used to store? This bit is, this means the first bit is deleted. This bit is used to store in the last place. Next, arithmetic shift, where it is used means in addition, subtraction, multiplication, division, we are using a arithmetic shift. First bit is used for representing a sign bit. Suppose if it is 1 means it is called as it is used for positive. Suppose if it is 0 means it is used for negative operation. First bit is 1 means which operation will be handled? Plus operation, that is addition operation is handled. If it is 0 means which operation will be handled? Subtraction operation is handled. That is the purpose of using a arithmetic shift left and arithmetic shift right. First bit is used as a sign bit. Next, suppose if you are having a overflow means overflow, underflow. What is the meaning of overflow and underflow? Empty. Overflow, when it will occur means when adding, addition, which one is occurred? Overflow. Underflow, deleting. When we are deleting an item from the memory means underflow occurs. What is the meaning of overflow means? Suppose if you are having a 1 liter of bottle, but you are pouring 2 liters of water means what it will happen? How many bits are overflow? 1 liter of water will be poured outside the bottle. It is called as a overflow. Underflow means all the bits are deleted from the memory. But still you are deleting means that is called as a underflow. Already there is no data item on the memory. But still you are deleting means it is called as a underflow. Overflow means the memory is fully filled. There is no space to fill the new data in the memory. Therefore, there is no space. That is called as a overflow. Underflow means you are deleting an item. There is no item to delete a data value in the stack or memory. For this purpose, we are using a overflow. Overflow means here it is used. This bit is used to represent a overflow or not. If overflow equal to 1 means overflow occurs. If it is 0 means overflow does not occur. That is the purpose of representing this diagram. How it is represented means arithmetic shift right. ASHR. Arithmetic shift right R2. And then arithmetic shift left R3. These two are used for representing in arithmetic operation. Arithmetic shift left, arithmetic shift right. Where it is used means division, multiplication we are using. First bit is used for a sign bit. Remaining bit only moved from one place to another place. Shifting means moving one data item one place to another place. Shifting means moving data item from one to another place. Next. That's all about the registers. Next one, what is the purpose of CPU? You have already know about the CPU. This is a central part of the system. And then next it is like a brain in the human body. Brain. See, what is the purpose of using a CPU means it is used to perform bulk of data processing operations in the system. It is used to perform a bulk of data processing operations in the system. What are all the three main parts used in a CPU? Arithmetic logic unit, that is a main part of the CPU. And then memory unit, control unit. Very good. These three are